electromagnetic pulses work. EMPs are devices that are capable of emitting a strong electromagnetic pulse that can destroy electronic equipment within a given area. The power of EMPs were discovered in 1962 during a US nuclear testing called Starfish Prime. A 1.44 megaton nuclear bomb was detonated over the mid-Pacific Ocean at an altitude of 400 kilometers above surface. The EMP created by the nuclear explosion traveled 1,445 kilometers to Hawaii, where around 300 street lamps and other unimportant electrical devices were destroyed. This demonstrated the potential power of the EMP. But how does an EMP actually work? An EMP sends a strong electromagnetic pulse that can be transferred to conductive materials. This pulse has a large current and overloads almost every electrical circuit it reaches. Let's say you go on a road trip, and due to your inability to decipher between your left and rights, you get lost and end up driving in the middle of a desert where a nuclear test is going on hundreds of miles away. The EMP created by the nuclear blast will reach your car, and the delicate circuits within your car that are meant to handle small currents are suddenly met by large electromagnetic pulses. This will send a large current into every circuit in your car and make other electronics around you fried. Therefore, your brand new car and phone are now fried and useless. However, you probably would have been able to escape had you had a car that was built before 1990 due to the lack of electronics back in those days. This is where the good old Yugo would shine, until you reach a hill, of course. But how did the nuclear bomb create these electromagnetic pulses to begin with? When a nuclear bomb explodes, not only does it produce blinding light and immense temperatures, it also emits three distinct electromagnetic pulses. The first pulse are gamma rays emitted from the explosion due to the immense energy release caused by the fission reaction. These gamma rays shoot out in every direction and collide with oxygen and nitrogen atoms, giving them enough energy to release one electron. These now free electrons come raining down to the surface in one big pulse due to the pull of Earth's magnetic field. This pulse mainly affects local antennas, short distance cable runs such as the cables inside a house, electrical equipment inside buildings. It also affects integrated circuits, sensors, communication systems, and much more electrical equipment. The second pulse consists of the high energy neutrons that fire off in every direction following the blast. These neutrons come from uranium atoms as they split up into lighter elements, which in turn create even more neutrons as they collide with one another during early stages of the explosion. I'll explain this elaborate process in detail in another video. These neutrons come down to the surface and mainly disrupt longer conductive wires such as residential street wires and vertical antenna towers. The final pulse temporarily distorts Earth's magnetic field for a few seconds due to the intense burst of electromagnetic radiation reaching the surface. This affects large power lines and underground wires. It's this pulse that will disrupt the power grid and cut power to millions of people. The first pulse and the third pulse do the most damage, while the second pulse is only effective because it happens milliseconds after the first pulse. The effects of the third pulse are similar to the effects of the natural EMP called solar flares. Solar flares occur when there is a large magnetic loop that forms around the sun's surface. When any one of these two loops of different magnitude collides, it creates a short circuit which releases an immense amount of energy at once, equivalent to around 100 megaton hydrogen bombs, or around 6,600 Hiroshima bombs. Then the energy travels through space, and depending on the timing and position, it impacts Earth. The electromagnetic pulse slightly distorts Earth's magnetic field, and is sometimes strong enough to pierce through the magnetic field, temporarily causing blackouts and electrical failures in some places on Earth. If this were to happen, most of Earth's sky would be covered by aurora borealis, or northern lights. The greenish light produced is the sun's electromagnetic radiation being blocked by Earth's magnetic field. Another example of a natural EMP is a lightning strike. When hot air droplets and cold microscopic ice pellets rub against each other in the sky, it creates an environment when the bottom of the cloud is extremely negative while the top of the cloud is positive. Once a cloud gets so negative, the energy is expelled to a positive surface, which can either be the ground or the top of another cloud. This quick discharge of energy creates an EMP, which if struck at the right spot, can cause an overload and fry the whole circuit due to the high currents of the lightning strike. Typically, the power of EMPs are laughed upon when being compared to what seems like more dangerous equipment, like nuclear warheads and ballistic missiles. However, especially in this day of age of electronics which almost everyone relies on one way or another, EMP attacks can be the most lethal or strategic attack given the right circumstances. Alright, thanks guys for watching another video, and I'll see you in the next one. Peace.